I can do math on a Friday. It's fine with me. All right, here we go. So example 1, in the figure below and to the right, an altitude is drawn to the base of an equilateral triangle. So it's an equilateral triangle, so it means all these angles are the same. All of these. Now notice they cut it down the middle there. It says if AC is 13, so this is 13, find C, the length of the altitude. So this is altitude. So notice they cut it up into a 30, 60, 90 triangle. So in a 30, 60, 90 triangle, I'm going to put the relationships right here. 30, 60, 90. By now, hopefully, it's becoming like pretty straightforward. And n squared root of 3 and 2n. And if I'm just looking at this triangle in red to help us focus, that 13 is like hypotenuse. So I'm going to put 13 there. So then that means the short leg is n. So I'm going to write 2n equals 13. So n equals 13 over 2. I know you can write this in decimal. What's that? 6.5, because 6 plus 6 is 12, so 13. Yeah, 6.5. I'm not going to write it at 6.5 because I don't think you'll see that answer in UH. And then they want, what do they want again? The altitude, the C. So to get the long leg, that's wherever the 60 degrees aims at, that's at n squared root of 3. So all you got to do with this n is multiply it by what? Square root of 3. So n squared root of 3 equals 13 square root of 3 over 2. And there it is. That's the answer. That's the answer you'll probably see. Cool or not cool? And that's it. You're done. All right. Let's go to the next one. Again, this is a 30, 60, 90 triangle. So I'm going to write 30, 60, 90, and n square root of 3 and 2n. And it says, given triangle ABC shown below, if AC is 9, so AC is 9, I'm going to write AC, I'm going to put 9 there. Find X and Y. So 9 is a long leg. So if 9 is a long leg, I'm going to put the 9 down here, and I'm going to write n square root of 3 equals 9. What you want is n, so I'm going to divide both sides by square root of 3. So n equals 9 over square root of 3, which is actually a perfectly acceptable answer if it were a free response. But the multiple choice on UH, it's probably not going to have this one because it wants you to rationalize it. So how do you rationalize it? Multiply that sucker by, square root of 3 over square root of 3. Make sure you put a square root of 3 on both because that's what makes it 1. Anything times 1 is itself. So then it becomes 9 square root of 3 over square root of 3 times square root of 3 is 3. And be careful, don't leave it like that. 3 goes into 9 how many times? So 3 square root of 3 is the answer. And I know some of you can probably figure it out without doing that. You'll probably just leave, like the only way to get to 9 is you go 3 times 3. So x has to be 3 square root of 3. So when I multiply that by square root of 3, the square root of 3 goes away and it just becomes 3. 3 times 3 is 9. I know some of you can do that, but it's better to show the work. And then from there, we haven't answered the y yet. We just got the x. Oh, actually, that's the y. We haven't gotten the x yet. So that's the y. We haven't gotten the x yet. The x is the hypotenuse. So all you got to do is just double the short leg. So just multiply this 3 right there by 2. What's 3 times 2? So that's what x is. 6 square root of 3. And done. D-O-N-E. And put a happy face. Oh, it's one of my better happy faces. Okay. Who do you guys want to say hi to? Because this is my YouTube channel. I'm gonna upload it. Assuming that they... Who's absent? Like, hey, Miss Smith. Hopefully you're watching this, and Seymour, right? Hey, Seymour. No, I know. I said that on purpose, guys. Don't get mad. Don't get mad, miss. Okay. All right, let's go to the next one. All right. So here you go, guys. Here's the next one. Suppose that theta is an acute angle of a right triangle, and that tan theta is 2 square root of 3 over 5. Find sine and cosine theta. So right here above example 3, write SOHCAHTOA. SOHCAHTOA. Once you're beasts, you don't have to write that anymore. But right now we're kind of rookies. We draw a right triangle. There's my right triangle, and I'm going to say that's theta. Remember that tan is opposite over adjacent, so this must be opposite, 2 square root of 3, and this must be adjacent, 5. It wants sine and cosine. I know I'm going to need the hypotenuse on both of those, so I'm going to solve for the hypotenuse on both of those. Here we go. I'm going to write 2 square root of 3 squared plus 5 squared, I'm going to put x there, equals x squared. So I'm going to square it, guys. 2 squared is 4, and then square root of 3 squared is 3. 4 times 3 is 12. And then 5 squared is 25 equals x squared. So x equals, I'm taking the square root 25 plus 12. 25, 35, 36, 37. It does not break down. It does not break down, just square root of 37. So x is the square root of 37. Now we're ready. So I'm going to write sine theta. Sine is equal to opposite over hypotenuse. 2 square root of 3 over square root of 37. You probably don't want it like that, so I'm going to multiply that sucker by square root of 37 over square root of 37. And when you do that, you get, let's see, 2 square root 37 times 3. Is that 111? 33, 33, 99. And I did that 3 times. 3, 4, 5, 6, 7, 4, 8, 12. 111. Unless I'm wrong. Let me know if I'm wrong. I make mistakes all the time. I make mistakes all the time, guys. Over 37. The square root of 111 does not break down. So there it is. Leave it like that. How do we feel? All right, we still need the other one. So I'm going to put the other one in black. Cosine theta is adjacent over hypotenuse. So I'm looking at my theta. Adjacent is 5. Hypotenuse is square root of 37. Multiply this by square root of 37 over square root of 37. And you get cosine theta equals 5 square root of 37 over 37. Excuse me. I don't know why I did a hiccup there. I can't control my hiccups, so if this happens. I don't know if you guys need to know this because it's not very important information, but you know how I can't sleep? You know what I did today? I went to Whataburger around 4:30 in the morning, and I have evidence. I texted some people at 5 in the morning, and let me tell you what I texted them. No, I'm not. You think I'm kidding? Look, there's my picture, and so there's a picture of me at Whataburger, right? With my laptop. I was working. See, there's my little folder, and I go, guess where I'm at? LOL, I'm having too much fun. Alrighty, nerds, going to create a quick lesson before my meal arrives. See y'all at school. Those were to some teachers, right? I texted Winners and Kilgore, but they didn't text me back. That was at 5. They probably were still asleep at 5 in the morning, but so yeah, you don't want my brain, guys, because you don't want to know. I'm so unhealthy. I got a patty melt. Instead of getting breakfast, right, I got a patty melt. But yeah, see, so I was there at 5 in the morning, guys, putting in grades and eating my breakfast and, well, my burger, I guess it wasn't breakfast, and typing out lessons, doing math life. So that, yeah, you don't want my brain, guys, trust me. All right. Yeah, this is what I do when I can't sleep. I just get up and go somewhere. But I take my bag with me so I can work, right? All right, next question, guys. Suppose that theta is an acute angle of a right triangle, and that secant theta is 13 over 7. All right, secant is the reciprocal of which one? It starts with an S, so the other one must start with a C, so cosine. 7 over 13. So that's what I would do first. And then I would go ahead and draw a right triangle. So here's my right triangle. Not to scale. I'm going to call this theta. And cosine is adjacent over hypotenuse, so I put a 7 here. I put a 13 there. And I guess I'm going to call this an x, because I'm going to need that. So here we go. So I'm going to go 7 squared plus x squared equals 13 squared. I'm going to move the 7 squared to the other side. So x squared equals 13 squared minus 7 squared. And I'm going to square root it. So the square root of 13 squared minus 7 squared. So I take my calculator, and I'm just going to do the 13 squared minus 7 squared in case it's not a perfect square root. So here's my calculator. Come on, buddy. Come on, buddy. I need a faster calculator. All right, here we go. 13 squared minus 7 squared. Push enter. Oh, I get a nice square root of 120, and that does break down. So square root of 120. If it were 12, 4 times 3 is 12, right? So that means 4 times 30 is 120. And which one of those is a perfect square root? What's the square root of 4? So 2 square root of 30. So that's what x is. 2 square root of 30. 30 doesn't break down. 5 times 6, but none of those numbers break down more. So how do we feel? All right, here we go, guys. Which one do you want to do first? Cosecant or tan? Doesn't matter to me. Tan? Okay, tan. Tan theta. Tan is opposite over adjacent. Opposite, 2 square root of 30 over adjacent. 7. Done. Now ready for cosecant, CSC. Cosecant is the reciprocal of sine. So instead of saying 2 square root of 30 over 13, you're going to say 13 over 2 square root of 30. But we got to rationalize it. So I'm going to multiply that sucker by square root of 30 over square root of 30. Sorry that I'm going into this next step right there. So let's see what we get. Cosecant theta is equal to 13 square root of 30 over 2 times 30 is 60. And I don't believe it simplifies, so there it is. And this one. How are we feeling, guys? Okay. All right, example 5. Hopefully these are not too extreme. Maybe you already have them memorized, but if you don't, that's fine. I want to turn these into degrees. So take your 7 pi over 6 and multiply that sucker by 180 over pi. The pi's cancel out, and you're going to get, I believe you're going to get 210. That's 7 pi over 6, yeah. So if you don't get that, just go 7, 6 times 180, and you'll get that 210. See? 3 pi over 2, that's right on the axis. That is 270, and make sure to put a degree symbol. Degrees. 11 pi over 12, that is not one of the perfect angles, so we're going to just 11 pi over 12 times 180 over pi. If you want to put the 180 for the pi, that's fine too. 11 12 times 180. So 11 over 12 times 180. What do we get? 165. So that's 165 degrees. How are we feeling, guys? We feeling okay? All right, let's go to the next. And actually, this many lessons on UH, but that's fine. We'll do it here really fast. What it means to find arc length, define central angle, and chat about. Okay, so what do we mean by arc length? And don't worry, we'll go fast. What was that? Arc length is like if I want to know what this is in sky blue. If I want to know that distance, that's arc length, and we're going to call it letter S. So the way they do it, or the way to do it, one of the easier ways is this. So S, which is arc length, equals, that is just a sector of circumference, or a portion of circumference. So do it like this, theta over 2 pi times 2 pi r, where theta, where that is your theta. That's the sector, right? They call that central angle. Where theta is your central angle. Notice these 2 pi's cancel out. So you get surface area. Arc length is equal to just theta r. That's only if you're in radians. So that's why it's so powerful. Now, if you're in degrees, S equals theta over 360 times 2 pi r. And nothing cancels, and you just leave it like that. This is if you're in degrees. How do we feel? So we covered arc length. We covered arc length in both radians and degrees. Now, and we covered what central angle is. That's your central angle. And now let's chat about areas. Okay, area of a circle. Area of a circle is pi r squared. Do you guys remember that from geometry? So area of a sector of a circle, assuming the same sector, is equal to theta over 2 pi times pi r squared. Notice that the pi's will cancel out, and you can write this, or I guess you don't have to, but you can write this as theta r squared over 2. Sometimes they write it as theta over 2 r squared. That's only if you are in radians. If you're in degrees, and I'll write it right here, area of a sector in degrees, it will be theta over 360 times 2 pi, not times 2 pi, that's circumference, times pi r squared. And this one you use only if degrees. We feeling okay so far, guys? Nothing crazy, right? Okay, here we go. And I'll draw it for you guys because I know you guys are visual learners. So look at this. It wants the arc length when theta is 240 degrees. So here's how it looks. Kind of looks like, have you guys ever played Pac-Man? Kind of looks like that, but the mouth is kind of open a lot. Let's see. It looks like not quite 270. So looks something like that, where this is 240 degrees. And they want to know arc length, so they want to know the distance of this in sky blue. So how do I get that distance in sky blue? You go S equals theta over 240. All wrong. Everything's wrong. 240 over 360 times 2 times pi times 6 centimeters. Because that 240 over 360 is like a percentage. That makes sense, guys? So then S equals, let's see, 24 and 36. I want to say that's 2/3 times 12 pi centimeters. And what's 2/3 of 12? 8. 8 pi centimeters. I could be wrong. I make mistakes all the time, like you saw a little while ago. But this is the exact arc length, so that's why I left it in terms of pi. So 240 over 360, I'm 99.9% sure it's 2/3, but let me check. 240 over 360. I push enter, and yep, sure enough, that's 2/3. Math, fraction, enter. And then I just multiplied that by 12, and times 12. And there's your 8, and then just put the pi. And this is the exact. If you round the pi 3.14, or you put 8 times pi in the calculator, as soon as it's a decimal, it's no longer exact. It's approximate. Cool or not cool? All right. Yeah, like let's say you don't like any of this. Chav, I don't like any of this. I just like this first sentence. Just do the first sentence. But don't put the pi in there so you can get a nice number like 8, like this. You can just go alpha y equals, enter. That gives me the little fraction. You can go 240 over 360 like this. And then you can just go times 2 times, what was it, 6? 2 times pi times 6. Don't put the pi in there so you don't, because you're going to put the pi in there, right? And there it is. You get 8, and then just put the pi. You know what I mean?
Yeah, I put it as pi squared rather than.
Oh, yeah, you're not squaring.
Instead of,
Yeah. All right, here we go, guys. We got another one. But this one, they're nicer to you. They say find the arc length when theta, they give it to you in radians. Notice that's a radian. So in case you want a visual, here's how that visual looks. Waka, waka, waka. This is 9, this is 9. And they want to know that in sky blue, S. That's what they want to know. Pi over 4 is just another way to indicate an angle. In case you wanted to know, pi over 4 is the same thing as 45 degrees. Arc length is theta times r, so pi over 4 times 9. So 9 pi over 4 yards. And that's it. You're done. Cool or not cool? You guys ready for the next one? All right. The next one says the word perimeter. What does perimeter mean? Yeah, what does that mean? What does that mean? All the outside, guys. Add up all, pretend like it's fence. All right, guys, focus. Perimeter means like if it was a fence, what does all the fencing add up to? So here's my central angle, 7 pi over 4. And here's my radius. So here's how this looks. So here's 10. and 7 pi over 4. So that's going to look like, let's see, 4, 8, 7. Oh, it's all the way over here. This is like waka waka. It's pi over 4 away from 2 pi. So that's how it looks. All right, another pi over 4 would be 2 pi. So it looks like that, guys. This is 10. This is 10. This is 10. And I want to add up this arc length. I want to add up that arc length. So here it is. Perimeter equals 10 plus 10. That's those, right? These 10s right here. Plus arc length, which look, they're giving it to me in radians. So times 7 pi over 4 times 10. See? So the perimeter is equal to 20 plus, and let me reduce this before 2 goes into 4 twice, 2 goes into 10 5 times. 7 times 5, what's that, 35? So 35 pi over 2, and I need units, feet. Put all that in parentheses like that. Feet. How do we feel, guys? Easy? Yes. Oh, well, remember that the arc length S is equal to theta R. Only if it's in radians. It's right here, watch. It's right here. Only if it's in radians. If it's degrees, we have to use this one. No, ask, miss. Ask. All right, here we go. Now we got a sector. So this sector takes up 135 degrees. It doesn't have to be perfect. So here we go. Like that, and 135 degrees, probably something like that. I want to know this area. The radius is 6. So here we go. I'm going to go area of sector is equal to 135 degrees over 360 degrees. So that acts like a percentage times pi times 6 squared. So I'm going to take my calculator and I'm just going to go 135 over 360 times 36. So I'm going to leave it in terms of pi. So here we go. Alpha y equals, to get the little fraction, 135 over 360. And I'm going to go times 6 squared is 36. Does everyone see where I got the 36 from? It says 13.5. I'm going to leave it as a fraction. So 27 pi over 2. 27 pi over 2. And I need units. How do you pronounce that? Centimeters squared or square centimeters? It's square centimeters, guys. No, it's not. When you, okay, look at the floor here. No, for real, everyone look at the floor. I'm looking at 1, 2, 3, 4. Do you say those are 4 tiles squared? Or do you say those are 4 squared tiles? 4 tiles. You say 4 tiles squared? 4 tiles. 4 tiles squared. No, 4 squared. What shape is those tiles? The square. So you say 4 square tiles. If they were shaped in a circle, you say 4 circle tiles. You know, because there's different tiles at the hardware store, right? So you say 4 square centimeters, or 27 pi over 2 square centimeters. Not centimeters squared, that's square centimeters.
So my question is, we're like, get it wrong if I say it that way.
If you tell it to a scientist, yes. No. A mathematician, they won't say it's okay. Every AP exam and blah, 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 when they don't put the units, when they spell it out, they'll say square centimeters. It's not centimeter squared, it's square centimeters. Okay. Yeah, whoever taught you, go back and tell them, like, why did you tell me centimeter squared? It's square centimeters. Taurus would not tell you. I'm sure Taurus told you square centimeters. I'm going to go talk to her. Square centimeters. Yeah. You don't say, oh, you're probably thinking because of x squared, y squared. But if it's like feet squared, you don't say feet squared, you say square feet.
Oh,
If it's
I've read that before.
if it's feet cubed, you don't say feet cubed, you say cubed feet.
Oh, look, square feet right there. Okay, no,
Square feet, cubed feet.
I've read it before.
Yeah. Yeah, when you read, because scientists and mathematicians know the right way to say it, right? So, all right, here we go. Doesn't matter. Let's go. Let's continue. A sector of a circle at central angle 7 pi over 4. So it's pi over 4 away from a whole revolution. And an area of 63 pi over 8 square feet. Find the radius of the circle. So now we're looking for the radius. So here's the visual for you visual learners. There's my visual. I want to find this area. Waka waka. This is what 7 pi over 4 is. All right. Next, they tell me what the area of that sector is. So remember, guys, area of a sector for a circle is theta over 2 pi times pi r squared, which I guess the pi's cancel out, and you can write it as theta r squared over 2. All right, that's if it's in radians only, right? All right, here we go. I'm going to fill this in. 63 pi over 8 equals 7 pi over 4 r squared divided by 2. So get it up to here. All I did was plug in. I haven't done anything crazy, guys. I'm going to do keep, change, flip. This 2, I'm going to put it right next to that 4. So what's 4 times 2? 8. So now here's what I have. 63 pi over 8 equals 7 pi r squared over 8. Are we still okay? I have 8 on both of them. The denominator of both are 8. So I can just set the numerators equal to each other. So that means 63 pi equals 7 pi r squared. Does that make sense? The pi's cancel each other out, or divide by pi, divide by pi. So you have 63 equals 7r squared. What am I going to do? Divide by 7. So 63 divided by 7 is what? I think it's 9. Yeah, 9 times 7 is 63. 9. And then how do I get r by itself? Take a square root. So r equals 3. And I need units. Nope, just feet. You square rooted square feet, so it's just feet. You square rooted square feet, so it's just feet, guys. Cool or not cool? Plus it's radius. Radius can't be square feet. Radius is just a length, so it's just feet. How do we feel? Do we feel okay? All right, let's go to the next one. Oh, these are the last two, because we're not going to do the last page here, because we're not ready yet. All right, here we go. All right, guys, focus, focus. A car has wheels with 6-inch radius. So it is a golf cart because we don't have cars this small in the U.S. So it's a golf cart. Yeah, if it has a 6-inch radius, that means the diameter of that wheel is 12 inches. It's small. It's a small vehicle. It's probably like a yeah, it could be a buggy because buggies are small. If each wheel's rate of turn, all right, guys, focus, focus, focus. If each wheel's rate of turn is 5 revolutions per second, so underline that, find the angular speed in units of radians per second. Okay, that's pretty simple. Here's how you're going to do it. I'm going to write 5 revolutions per second. I'm kind of doing stoichiometry, dimensional analysis. In 1 revolution, how many radians do I have? In 1 revolution, how many radians do you have? 2 what? 2 pi. Make sure you write the word radians. In 1 revolution, you have 2 pi radians. Revolutions cancel out, and there it is in radians per second. What is 5 times 2 pi? So 10 pi radians per second. That's your answer. How do we feel? Do we feel okay, guys? All right. Example 12. Don't worry, last example, and then we'll tell you guys what we're going to do next. A car has wheels with a 9-inch radius, so a little bigger car now. Not as big as what we have now, but a little bigger. If each wheel's rate of turn is 6 revolutions per second, how fast is the car moving in units of inches per second? Okay, so here's what we're going to do now. 6 revolutions per second. In 1 revolution, how much distance do you cover? Well, whatever the circumference is. So you're going to write 2 times pi times 9 inches. That's circumference. Circumference is 2 pi r. Do you guys see that? All right, there you go. The revolutions cancel out and you get inches per second. So I take my calculator. I'm going to leave it in terms of pi, guys. So I take my calculator. I'm going to go 6 times 2 times 9. 6 times 2 times 9. And I get 108. And I put the pi back in there. 108 pi inches per second. If there's units, you should always use units. That's how fast this is going. Chav, I want to know what that is in actual units, because I don't know what pi is. All right, well, it's traveling, let's see, 108 times pi times, it's traveling 339.3 inches per second. Whatever that many inches is per second. Cool or not cool? All right, so here we go. Here's what I'm going to let you guys know, guys. Now that we've done this, you should be able to get a 100 on what quiz? UH right triangles and sectors. We've covered all the questions that are hard, quote unquote. We covered all the questions that are hard, quote unquote. So this is going to be, it's 9 o'clock. You have an hour. That's more than enough time to do one full honest attempt. So this will be the last day that we'll let you use class time to take your UH quiz. And when is this due? Friday. So if you get 100 right now, you can be done with it. So that's it, guys. We're done. Make an honest attempt. And then we'll continue on.